Hi! Hello! Welcome back to Gillesania Engineering Videos, your daily supply of solutions to engineering problems. If you like what you see, please subscribe and don't forget to hit the bell icon so that you'll be notified every time we upload new videos. In this video, we will solve problems in civil engineering. Mostly recent board exam questions and other similar problems. So we have these solved problems in civil engineering. And by the way, this is coming soon to our new tier. We call it the GERTC Plus. So at present, we have our GERTC Lite, in which you will enjoy all our review courses for 13 weeks. Yung 13-week review namin at the palm of your hand. And that is very affordable. It will only cost you 499 pesos for 30 days. 30 days after you join. No? You can pay through GCash or through PayMaya. Okay? And coming soon is our GERTC Plus. So, coming soon pa yon. And this feature that we are going to discuss today, itong ipapresent ko sa inyo, is part of our GERTC Plus. In our GERTC Plus, you will enjoy all the features of our GERTC Lite, plus yung mga solved problems, particularly yung mga recent board exam questions. Okay? So, I hope you will learn a lot from this video lecture. Alright, let's continue. Solve problems in civil engineering, HGE Part 8. Part 8. Recent board exam questions and other similar problems. Okay, let's have problem number 48 to 49. And this is November 2019 exam. Actually, isa lang yung tanong dito, pero dinoble ko lang yung tanong. I added a question number 49. A closed cylindrical tank, 1 meter in diameter, and completely filled with water is rotated about its vertical axis at 1,200 RPM. Alright, the question is the increase in pressure at the rim of the tank, at the top. At the rim of the tank, the increase in pressure. Okay, so I added another question, the total force acting on the top cover of the tank. So, closed cylindrical tank, completely filled with water. Ito yun. The diameter is 1, so the radius is 0.5 meter. Okay, gano'n, no? Tapos, papaikotin natin. So, what will happen if that is rotated? So, the tank is filled, completely filled with water. There's no air inside. So, there will be an imaginary paraboloid on top. That paraboloid, as you rotate that, let's say, mahina lang muna, yung paraboloid na yan will represent the hydraulic grade line. Itong line na ito. So, the level to that is the pressure head. So, kung mahina lang yung omega natin, ganon yan. Palakasan natin yung omega, gaganon yung lalaki yung parabola, tataas, kasi malaki yung pressure increase niya. Okay? And so on. Ayan. So, ganun yung mangyayari dyan. So, ito yung ating, the pressure increase at the rim. Ito yung rim natin. It will be the rise. The pressure rate increase is the rise in this, the height of this parabola. So, tawagin natin yung Y. Your R is 0.5. So, the height of paraboloid is equal to omega squared x squared divided by 2G. Here, your X is equal to 0.5. Your omega is 1,200 RPM. Convert natin yan into radians per second. Times pi over 30. So, ito yun. Alright. So, itong pi over 30 is conversion from RPM to radians per second. So, ito yung X natin. Pinaka-R natin is the X. Ito kasi yung X. Ito kasi yung X. Ito yung Y. Ganun kasi yung principle dyan. So, bali yung coordinate nung palitan ko yung pointer ko, Ito yung pinaka-X mo. Alright? Ito naman yung Y mo. Ayan. Okay, so with that, makukuha natin yung Y, 201.2. So from wala, initially, to that. So the increase in pressure will be the gamma times that Y. As what I've stated kanina, this line represents the hydraulic grade line or the pressure gradient. The pressure grade line. Any measure from that line to the top, here, ito yung increase in pressure at that level. So at the rim, ito yung kanyang increase in head. So the pressure increase is gamma Y and that will be give us 1,974 kilopascal. So that is letter D. Alright? Okay, the second question is, what is the total force acting on the cover, top cover of the tank? Okay, how will you compute that? How will you compute that? Okay, to do that, you compute the imaginary volume of water right on top. Ito yon. Itong sinidan ko, no? Have you noticed that? Ito. Ayan, itong part na yan, shaded na yan. Okay? So, the weight of that imaginary volume of water there, that is the total force acting on top. Pag ganun yan, no? So, computein natin yung weight of that, no? So, we need the volume. So, the volume is equal to, so alam natin that the volume of paraboloid of revolution is 1/2 pi x squared y. That's the volume of this paraboloid. Well, of course, common sense, the volume of this remaining will also be 1/2 pi x squared y. Correct? So that will be unit weight times the volume shaded. And that will be unit weight of water times 1/2 pi x squared or 0.5 squared times y. The same y kanina. Na? So that will give us 775.1 kilonewtons. That's the total force acting on top. Okay? Klaro ba? Okay, sige. So, that's it. Let's have another problem. Problem number 50. November 2019 pa rin. Okay, November 2019. A capsized bangka or small boat weighing 12 kilonewton rests on a seabed. It is decided to raise the bangka by attaching an inflatable balloon to it. Evaluate the minimum volume of the balloon to raise the bangka. No? So, the specific gravity of seawater is 1.03, and we will just neglect the weight of air and the balloon. Okay? So, and we will assume that there is no, volume displaced ng bangka. Yung weight niya, net na yun. Na? So, net weight na yun siya. Na? Kumbaga, itong 12 kilonewton, net weight na yan, bawas na dyan yung buoyant force kasi walang binigay na volume displaced of the bangka. Na? So, ito yung ating illustration. So, we have resting on a seabed. So, we are going to lift that up by attaching an air balloon. So, ganun yan. Aangat yan. So, ano yung minimum volume of the balloon para maalsa natin yung bangka? Na? So, the weight of the bangka is 12 kilonewton. As what I mentioned, we will assume that net na ito. Bawas na dyan yung buoyant force. Effective weight niya na yan, in other words. And of course, the buoyant force included here is the buoyant force of the balloon na. So we will neglect the weight of air and the weight of the balloon. So buoyant force equals the weight. The buoyant force of the balloon is equal to the unit weight of seawater times the volume of the balloon. Yun yung hinahanap. And that's equal to the weight. So the unit weight of seawater is 9.81 times 1.03. Okay? The weight of the bangka is 12. Then, makukuha natin yung minimum volume of the balloon. So, that will give us 1.188 cubic meters. No? So, 1.19. So, minimum yan. The bigger, mas maganda. Mas mabilis siyang aakyat. Okay? Well, kung meron pa ditong volume displaced ng, halimbawa, yung weight na binigay, not including the volume displaced of the bangka, then we will include the buoyant force acting on the bangka. If that, given yung volume displaced niya. Na? Okay. Yun. Sige. Sige, next problem. Problem, by the way, yung November 2019, halos lahat yata talaga, lahat ay itemized. Walang situational. Lahat itemized. 50 items. Alright, next problem. 60. November 2019 pa rin. Find the capacity in cubic meters per minute of a 1 meter diameter pipe with a head loss of 3 meters per kilometer and frictional factor of 0.025. Friction factor yung ibig nga sabihin dyan. So, we will use the Darcy-Weisbach formula. Okay? So, the formula is head loss is FL over D times velocity head. And alam natin that for circular pipe, velocity head is equal to B squared over 2G. V is Q over area. So, area of the circle. So simplifying that, it will be in terms of Q, that is 8Q squared over pi squared G D to the fourth. Magandang ma-memorize mo rin to, no? Any unit will do here. Any unit will do. That is the velocity head in terms of the discharge. So that if you will substitute this value here, ilagay mo yan dito, ito yung magiging expression niya. Na? Or simplifying that, that will become ganon. Or kung SI yung formula mo, SI yung unit mo, that is equivalent to 0.0826. Kasi yung pi mo, G mo is 9.81, no? FL Q squared divided by diameter raised to pi. Pareho lang yan. Pareho lang yan. Ginawa ko lang yan para maging generic siya. Any unit will do. Any unit will do. You can check on that. No? So, 8 divided by pi. 8 divided by pi squared. So, by pi. Shift pi squared. Divided by 9.81. Yan yung ginagamit natin. 0.0826. Actually, 0.082626. 0.08263 to be exact. Na para mas accurate siya. So, you can use that. It's up to you. Walang problema yan. Alright. So, here, the length is, the head loss is 3 meters per kilometer. So, meaning, the head loss is 3 meters, length natin 1 kilometer. The discharge ang hinahanap. The friction factor is 0.025. The diameter is 1 meter. So, your diameter here must be in meter. Your Q is cubic meter per second. L is in meter. Head loss is in meter. So, substituting the values, ito yan. The length is 1 kilometer or 1,000 meter. Diameter is 1 ito. Kamali ako. Sandali. Alright. So, tama. 1, no? Your diameter must be in meter. Length, meter. Q, cubic meter per second. Head loss is in meter. Alright, solving for Q, that will give us 1.205 cubic meter per second. But the required is cubic meters per minute. So, convert natin yung second to minute. So, we know 60 seconds is 1 minute. So, this will give us 72.3 cubic meters per minute. May problema ito sa board exam kasi wala sa choices. Wala sa choice itong value na to. No? Maraming na talaga. Madali lang naman. No? Sayang. Okay. So, next problem. Problem number 61. November 2019. A piece of wood, 0.6 meters square. So, 0.6 by 0.6. No? Iba yung 0.6 square meter. So, 0.6 meter square. So, 0.6 by 0.6. And 1.8 meters high floats in water with 0.5 meter outstanding. So, mayroong protrusion on top of water of 0.5 meter. Find the weight of the wood. So, buoyancy. Ito yun, So, 0.6 by 0.6 yung cross-section niya. And then, 1.8 meters yung height niya. So, when floating in water, of course, vertically, then, meron siyang 0.5 meters on top. Outstanding. Yan. Outstanding. So, kung 0.5 yan, the depth here is 1.3. Ang tanong dito is the weight of the wood. So, to solve the weight of the wood, kailangan natin ng unit weight ng wood. Of course, equilibrium tayo, buoyancy. So, we have the forces acting on this are the weight of the wood and the buoyant force acting on the wood. Okay? The weight of the wood is equal to the unit weight of the wood, which is unknown, times the volume of the wood. So, the volume is 0.6 by 0.6 by 1.8. So, padali. So, we have this already in terms of the unit weight of the wood. Okay? And the buoyant force naman is the unit weight of water times the volume displaced. The volume displaced is 0.6 by 0.6 by 1.3. Ito na. Alright. Then, of course, equilibrium tayo. Sa measure of forces vertical zero, the weight of the wood equals the buoyant force. Okay? The weight of the wood and the buoyant force. Okay? So, makakancel yung 0.6 squared, mabawala. Ang matitira dyan is the weight of the wood is equal to the 1.3 divided by 1.8 times the unit weight of wood. Okay, notice the formula. Pwede mo yung ma-memorize. If this is the draft, and this is the height of the wood, okay? The unit weight of the wood is equal to the draft divided by the height of the wood times the unit weight of water. Itong object din. Object. Unit weight of the object. Ito unit weight of the liquid. Kung whatever liquid is that. Na? Whatever liquid is that. Pwede mo yung ma-generalize. Ito yung unit weight of the object. Na? So, draft, ratio ng draft to the original height. That is kung prismatic. Meaning, the same ang cross-section from top to bottom. Ito prismatic kasi siya. No? So, yun yung general. Okay, in terms of draft. Uniform horizontal cross-section. Alright, so substituting the value, unit weight of wood is 9.81. Then, makukuha natin yung unit weight of the wood. So, unit weight of water, 9.81. Then, ang tanong dito is the weight of the wood. So, we have the weight of the wood is equal to the unit weight times the volume. The volume is 0.6 squared times 1.8. Okay? So, the answer is 4.59 kilonewtons. Okay, mabilis. Madali yung madali talaga kung alam mo yung ginagawa mo, pero kung nagme-memorize ka, patay, ha? Kaya panoorin niyo lang ng panoorin yung video, mamaster niyo rin yung dapat yung nasa isip mo is to understand the principle. Wag yung to memorize the procedure. Kasi kung yun yung mindset mo, memorize mo siya. Kapag i-twist yung tanong, mawawala ka na. Ha? Dapat yung talaga, principle. Focus on the principle. Alright, next problem. 62. November 2019. Rotating vessel. An open cylindrical tank, 1.3 meter in diameter and 2.1 meters high, is 2/3 full of water. The tank is rotated at 87 RPM about its vertical axis. Obtain the volume of water spilled. Okay, ano yung ma-spill out? So, open yung tank. Kanina, we have closed tank, na? So, walang matatapon doon. Alright, ito yun. Illustrate muna natin, ha? Ito yung ating tank. 2.1 meters high, 1.3, so the radius is 0.65. And then, 2/3 full. So, 2/3 of 2.1 is 1.4, di ba? 1.4, 7, 14, 21. So, 1.4 ang kanyang depth. So, there is a 0.7 meters headboard, no? Doon sa taas. So, rotated about this axis. Ito yung ating cross-section. And yan. Kasi ito yung agitator natin. Ikot-ikot yan. Alright. Ano ba yung principle dito? Paano mo ma-compute yung volume spill? O paano mo malaman kung may matatapon? Ito yung principle, ha? When you rotate that about this axis, okay? Kapag wala pang matapon ng liquid, gaganon yung behavior niya. No? The paraboloid will be formed and the height of the paraboloid y will be bisected by the original level. So, mababa, palaging ganun yan, basta wala pang natapon. Ibig sabihin, y/2 yan, y/2. If that is the case, then there is no liquid spill. Alright. Now, here we are given the omega and the radius. Makukompute natin yung y. No? Your omega is 87 RPM. So, 87 times pi/30. Your R is 0.65 or that's your X or your R. Masosolve natin yung Y. Na? So, ito conversion yan, ha? Ito yung R, ito yung, of course, 2G. Okay, the height of the parabola is 1.787. So, ang tanong is, may matatapon ba? Okay, you divide it by 2. Na? Y/2 is, that is 0.893. Look, lagpas ng 0.7. Lagpas ng 0.7. Ibig sabihin, may matatapon. It will not remain there, no? The maximum y/2 na walang matapon is 0.7. Or the maximum y na walang matapon is 1.4. Gets nyo? So with that, may matapon na siya, no? So some liquid will be spilled. But the height of the parabola is 1.787. It will not reach the bottom. The vortex of the parabola will not reach the bottom because the height of the tank is 2.1. So ganito lang siya, oh. Look. Ganon. Mabilis yung ikot niya. Ganon siya. So, this is 1.787. Ito yung original level ng water before we rotate that. So, how do we compute the volume spill? Now, to compute the volume spill, mas magandang gamitin yung air. The initial volume of air before rotating the tank is ito. Diba? Meron yan. Now, the volume of air during rotation is ito. Natural, kung may matapon, mas lalaki yung volume of air. Correct? Itong volume na ito, and that is the volume of the paraboloid of revolution. And we know the formula for that, no? 1/2 the volume of the circumscribing cylinder. So the volume spilled is equal to the volume of this paraboloid of revolution. We call it the final volume of air in the tank minus the initial volume of air. So that's how we do that. Na? So the volume spilled is the final volume of air minus the initial volume of air. Okay? So yun. The final volume of air is equal to 1/2 pi r squared times 1.787. Ito, paraboloid yan. The initial volume of air naman is pi r squared times 0.7. Yun, cylinder lang. Itong nasa taas. Na? Itong nasa taas na yan. Yun yung initial volume of air. Okay? Kaya na mag-simplify. You will get here 0.2568 cubic meter. Okay, the question is in liters times 1,000. Okay, take note, 1 cubic meter is 1,000 liters. So that's 256.8 cubic or liters, na? Letter B. Letter B. Ayos. By the way, that's another way to do this, na? Pero be careful lang, ha? Okay, ito yung principle dyan. Kapag pinahinto natin yung ikot nito, halimbawa, kasi ito hindi na umabot sa ilalim. Kapag huminto yung ikot yan, the water will rest exactly at y/2. Here. Dito mag-i-stop yung ating rotation. So meaning, itong depth na ito is kalahati ng 1.787. Ilan ba yun? 1.787 divided by 2 is 0.8395, no? Tandaan nyo, 0.8395. So meaning, may nawala na bumaba yung depth niya, no? I-minus natin ng 0.7. So, minusan natin to ng 0.7, 0.1395. 0.1395. Gets nyo? Alright. So, to compute the volume spill, ito. That's the volume spill. Obviously. Common sense. Sige, subukan natin. Ano yung volume niyan? Okay, area ng base, pi r squared. Pi times 0.65 squared times 0.1395. Okay? 0.185. Bakit yun? Sandali. Sorry. Nabaliktad. 1935. Ano ba to? Ba't ko ba? 19.1935. Nabaliktad. Ito. Sandali. I-reason ko, ha? Ito yung mahirap sa 0.1935. 1935. Rumble. Okay, bear with me. 0.1935. Alright. Sige. So, 0.1935. Ituloy-tuloy lang natin. Times pi r squared. Pi r squared. 0.65 squared. Okay? 0.2568. Okay, yun pa rin. Ganon yun. Ha? Pero be careful, ha? Kasi, didiscuss ko na ito noon sa review, tapos, yung mga estudyante, hindi nag-iisip, o baka walang isip. Kung halimbawa, meron ka ng imaginary paraboloid sa ilalim, then, if that will stop, it will not rest at y/2. Hindi na. Ibang usapan na yun. Ibang usapan na yun. Isipin nyo na lang. Okay, try to use your, basta the principle kasi dito is the volume of paraboloid of revolution equals 1/2 the volume of the cylinder. Okay, out of that, kaya na-conclude natin na pag huminto to, nasa gitna ito dapat. Gitna nung height na yan. Pero kung lumagpas na to sa ilalim, hindi na. It will not be at the middle of the height of the parabola. So, anyway, isipin nyo na mabuti. Baka gawin nyo yung gawa kayo ng principle, sarili nyo lang. Alright, sige.